Hey y'all, and welcome back to Coding with Minmer. On today's agenda, we're going to tackle Leetcode problem 56, merge intervals. After that, we'll go over an actual variant of the original question that Meta asks. They're pretty obsessed over this variant and just interval problems in general, so it's worth it to learn it. Okay, on to the problem statement. We're given an array of intervals where each interval has a start and an end. What we want to do is merge all the overlapping intervals so that the result is non-overlapping, and return an array of the non-overlapping intervals. Let's break everything down and work towards our solution. The first question is, what is meant by overlapping intervals? Taking a look at this example here, we have two intervals. We'll refer to this one as the previous interval and this one as the current interval. We can obviously see that they're both overlapping, but how can we tell in code? Well, if we just assume that the previous interval started earlier than our current one, because 1 is less than 3, then that actually helps us deduce whether the two are overlapping if the current interval also started before the previous one ended. So putting those two thoughts together, it's when the current interval starts after the previous one's start and before the previous one's end. That makes logical sense to me. Let me show you the other possibility. Say you had another interval right after that starts at 11 and ends at 13. If this is the current interval, then once again the previous interval starts earlier. So we can deduce that if the current interval starts after the previous one ended, then the two are not overlapping. They obviously would be overlapping if we had something like this, but that's not the case. So for these inferences to work, we will assume the intervals are given to us in such a way where they're sorted by increasing start. Here we have 1 to 3 to 11. It's only ever increasing. From this, we can actually deduce something else. That if the intervals are given to us in this way, it only makes sense then to iterate left to right. That way, on any given current interval, we can simply compare it with the interval before, and if they overlap like these two here, we'll merge them into a resulting list, and as you'll see, we'll call it result to hold the merged interval. This then will represent our answer so far. Let's go through a workflow and see how this might work. On the first iteration, this is our current interval. We obviously don't have a previous interval at all, so for all we know, it doesn't overlap with anything. Let's push it into our resulting list. Remember, we called it result, and it'll hold the interval 1 to 5. More formally in code, if our result is empty, then we'll just push the current interval. Yes, I'm aware that the current interval will overlap with the very next interval, but we're in a for loop left to right, remember, so we won't know this until we get to that interval. On the next iteration, this is our current interval. Of course, here's our previous one. Do they overlap? Yes, they do. Our current interval started before the previous one ended. 3 is indeed less than 5, but the question now becomes, how exactly do we merge the two? Just looking at it, we know we want an interval that stretches from 1 to 10, but how do we achieve this? Well, since we're visiting each interval in increasing start, 1 to 3 to 12 to so forth, then the earlier interval will always be processed first. And as you can see, here it is in our result. Therefore, for the merged interval, we never have to modify the start at all. It remains the same at 1. As for the end of the merged interval, we observe that we take the higher of the two ends between the two intervals, because that dictates when the merged interval ends. So we'll just take the max of these two interval ends, and whichever one is greater, here it's 10, we'll modify our merge result so far to take that on. Is the 10, let's X out the 5, and verifying that indeed, that looks correct to me. Now, another thing to note, we modified our merged result and not the actual previous interval in our input. Why was that? I mean, we could have, but had we expanded this interval to the 10, then we would have needed some logic to remove this current interval. That, however, is a big O(n) operation in an already big O(n) for loop that would yield an n squared time complexity. That's not ideal. We'd very much rather build our answer in external storage so that we can simply return it at the end of our function. Okay, moving on. Our current interval is now here. We'll ask the same question. Do these two overlap? No, because the current interval starts after the previous one ended. 12 is greater than 10. Now, in the case that they're both non-overlapping, we'll just push it into our result, like so, from the 12 to the 19. we generalize our rule that we only ever push to our result if our result is empty or we have non-overlapping intervals. On the next iteration, we have this current interval. We compare it with the previous one. They overlap because the current interval started before the previous one ended. 14 is less than 19, so we will merge them. And just as an FYI, even if the previous interval, say, ended at 14, these two would still be considered overlapping. Check out LeetCode's second example where that is the case. One ends the same time the next interval starts. But anyway, let's merge these two. Remember that when we merge, we don't touch the start at all. It remains unchanged. That makes sense. We don't shrink it to somehow start at the 14. Because just looking at it, the merge interval would start at the earlier start. As for the end of the merge interval, we take the max between the two intervals, 15 and 19, and modify our result to take on the higher value. That's 19, so I guess nothing changes. Great. Let's move on to the last iteration. Here's our current interval, and for reference, here's the previous one. Do they merge? No, they don't. 17 is higher than the 15. It started after the previous one ended. Okay, great. Let's push it into our result like so. But hold on. If we push that to our merged result, then we still have two intervals we still have to merge. That's a problem because we want our result to hold all the merge intervals where there's no overlap whatsoever. We realized that on the previous iteration in our loop, we merged these two in such a way that led to another merge with the interval right after. This 17 clearly started before the previous one ended. Therefore, on any given iteration, we compare the current interval not with the previous interval in our input, called intervals, but rather we compare it with the most recent interval in our result so far. Otherwise, if we did a comparison with the previous interval in the input, as you saw, we'd miss a merge. And furthermore, our result represents our answer of merged intervals after all. So it's only correct to compare it with it. Okay, let's do the merge real quick. The 12 remains the same, but what is the greater n between the two intervals? Is it the 25? Or in our result, now that we're checking the result, the 19, it's the 25. So let's expand and stretch this interval and modify it to take on the 25, no longer the 19. All right, and with that, we finish our loop. We've exhausted all the intervals and we have our answer. But there's one final issue. All this time, we made a huge assumption that the intervals were given to us sorted by the start. Remember, from increasing 1 to 3 to 12 and so forth. We did this because it helped us deduce a lot of intuitive logic, aka being able to compare intervals to know that they're overlapping or not, but also looping left to right to make these overlapping checks in the first place. Sadly though, this assumption is not true. There's nothing in the problem statement that says the given intervals are sorted. So for all we know, we could have been given them in reverse, that this interval was given first in our intervals input, this one second, this one third, fourth, and fifth. So how do we still loop through our intervals in ascending order of the start? Do we really loop through each time to find the earliest start interval and then have a nested loop to go over our result so far to see what's mergeable and what's not? As a quick example, we would loop through our intervals, visit the first one and say, well, 17 is not the lowest. On the second interval, it's not the 14 or the 12, the 3. Finally, on the last iteration, we find the 1. This is the current interval of interest. Let's have a nested loop to insert it into our result. Let's just temporarily draw that out for now. And we go on to the next iteration. We try and find now the second earliest start interval. It's not the first one. Is not the second interval, it's not the third, but it is the fourth. So now that we found it, we're gonna go into a nested loop through our result so far to see what's mergeable. Here it's mergeable, so we end up extending it to the 10, remember, and we repeat. I'm not gonna entertain this solution for too long. Needless to say, this is very inefficient. A nested loop means we're at a n square time complexity. We don't want exponential time complexity, so what's better than this? Well, we know that big O1 is not possible, and big O(n) isn't either. As we saw, we can dispatch a single loop to find the earliest start interval, but we need another n-1 loops to find the second earliest, third earliest, and so forth. So that's not possible. what we're left with is n log n. What I'm hinting towards is that we should use a sort function, an inbuilt sort function, that in the very beginning of our merge intervals function will sort all of our given intervals by increasing start. Then we can go through the left to right loop that we just went over, and all is good again in the world. I know it was a long way coming to realize this, but I wanted to make sure we had the intuition down before introducing the obscure sort solution to the problem. Ultimately, our answer of result holds a 1 to 10 interval and also a 12 to 25 interval. And that's what we'll return. The overall time complexity is n log n because of the sorting, and the space complexity would be log n or n depending on which sorting algorithm was used. That's not too important, but it may be good to quickly point out in the interview. But alright, with that said, let's code this up. Okay, so recall that before anything else, including our left to right loop, we're going to pass in the pointer to the first interval as well as the last one. And with that, our intervals be sorted by the start time. This by default will sort by ascending order of the first element, which happens to be the start. That's exactly what we want. After that, let's ready our result that will ultimately return. Remember, it's a 2D matrix, and we called it result. Let's return it before I forget later on. And then now finally we can get to our loop. On each iteration, we'll call it the current interval, and we'll loop through all of our intervals. Now remember, there are two cases where we're going to simply push our current interval into our answer. It's when the result is empty or the current interval started after the most recent interval in our result. Therefore, they're not overlapping. If one of the two is true, we're going to push it back into our answer. There we go. Let's get rid of the curlies to make this a little bit more compact. Now let's have an else statement that if this is not true, they must be overlapping. We only ever modify the end of our merge interval by taking the max between the current interval of interest and our result so far. The start remains the same. Okay, and with that, that's actually all the code. Let's move on to the variant. Okay, so there's a small percentage you'll be asked the original LeetCode problem, but it's more likely you'll be asked this variant. Let's read the problem statement over. We're given now not one, but two array intervals named A and B, where A has no overlap within A, which as you can see here, that's true between these two intervals, these two and these two, and the same deal with B. And verifying that, of course, is true. Not only that, but here's one very important note. Unlike the previous problem, our given interval lists A and B are both already sorted by the start in ascending order. So for A, the interval starts at 3, and then the next one at 14, 18, 23, 25, it's increasing. Additionally, each interval still has the same start and end. This interval here, for example, in B starts at 2 and ends at 8. Our goal remains the same. We want to merge all the overlapping intervals between the two interval lists, A and B, into a result, where the resulting intervals then are all merged. Don't at me, this is not to scale. Something like that. Now to solve this, we carry the same idea from the original LeetCode problem. We still want to process each interval in increasing start. So ideally, we visit this interval in B first because it has the earliest start of 2. Then, after that, we visit the interval in A because it starts next at 3, the next soonest one. And then the 13 to 14 to 18 to 23, and finally 25. The initial thought is, why not just loop over an interval list, say A, for example, and push them all to the end of B. Then, once all the intervals in A are in B, we can just resort all those intervals by the start, and just like that, we've transformed the variant back into the original LeetCode problem. We can reuse our whole looping algorithm that we had from before. The time complexity would be A plus B log A plus B because sorting is the bottleneck. However, this is not good enough for meta. Why would we resort all the intervals when they're already sorted within their own respective interval list? Let's be a bit smarter about this. Since we're given 2 and only 2 interval lists, why not use a 2-pointer approach and have one pointer, let's call it I, that points at the first interval of A, and another pointer J that points at the first interval of B. Then we can loop, and on any given iteration, we can check between the two intervals that our pointers are on, and we ask this question: which interval started earlier? Here, that's obviously this one because 2 is less than 3, it started sooner. With this, we can reuse the same merging logic from before. That, remember, our result is empty, let's just push this interval into our result, like so, 2 to the 8. To repeat, remember, this is the first interval. There's literally no previous interval beforehand. There's no merging to be had yet. After this, whenever we've processed an interval, we should also increment the corresponding pointer. Here, that's j, that points at this interval now for the next iteration. So moving on, in our second iteration, we ask the same question: which interval started earlier? Well, it's the one in interval A because 3 is less than 13. Great, this is the current interval of interest then. Let's compare it with our most recent interval in result and realize that the two are overlapping. And following the same train of thought from the previous problem, our current interval started after the previous intervals start, but before the previous intervals end. The 3 is between the 2 and 8. Let's merge the two. The start, of course, always remains unchanged because we process intervals by the earliest to latest start, so the interval already in our result has the desired start time. But for the end of our merged interval, we take the max, remember, between the two ends. Which one's higher, the 11 or 8? It's obviously the 11. Let's modify our interval in our result to stretch to that 11 and take that on, no longer the 8, and here's the merged interval. I hope this logic isn't total whiplash. We derived this in the original LeetCode problem. Lastly, remember to increment I, and we move on in our loop. On this iteration then, which interval started earlier? It's the interval that started at 13, not 14. We'll compare this current interval then with what we've merged so far to see if there's overlap. In this case, however, our current interval started after the previous one ended. Since that's the case, we're gonna push the interval into our result from 13 to the 20. Remember to increment j, and look at that, we've exhausted every interval in B. This is actually a problem because we still have intervals left to be processed, namely this one, this one, this one, this one. But if we kept going in our loop, we'll be accessing this interval in A, that's fine. With an interval, however, that just doesn't exist in B, our code explodes. So what do? Well, we can use a while loop to loop as long as the two pointers are both in bounds. The moment one reaches the end of its interval list, such as this one here for interval list B, then we can have an easy if statement to check, hey, which pointer is still in bounds, I or j? Obviously that's I. And we'll loop over the rest of its intervals in interval list A and merge in the same way that we did before with our result so far. Okay, so let's do just that. This is the current interval of interest. Does it overlap with what we merged so far? Indeed it does. Which n do we take, the 15 or the 20? It's the 20, so we overwrite 20 with 20, so nothing really changes. Increment I to the next interval, and on the next iteration, you have this current interval of interest. It also overlaps with what we have. 18 starts before the previous interval ended. Therefore, let's merge the two. The 13 remains unchanged, of course. But between the 20 and the 22, we're going to stretch the most recent interval to the 22, X out the 20, and we move on. I is now on the next interval, 23 to 24. Let's speedrun this. This does not overlap with our interval that ends at 22, so let's just push it to our answer like so, 23 to 24. We increment I to the last interval where we'll do the same thing. Let's push it to our result. We have 25 to 26 because it doesn't overlap with our previous interval. We increment I one last time, and we've now also exhausted all the intervals in interval list A. What is our ultimate answer that we return? Well, we have an interval 2 to 11, 13 all the way to the 22, and then two more intervals that never overlap. That's okay, 23 to 24, as well as 25 to 26. And it's a 2D array that we return. There you have it. Now, I'd like to think that this variant really just adds another layer of thinking to the original LeetCode problem. Kind of like a wrapper function over internal functionality, and there is actually some truth to this. The way we chose to iterate with I and j, sure, is different. But once we find the current interval of interest, we'll reuse the same pushing and merging logic. You'll see that in the code implementation. Alright, the time complexity has been improved from the sorting brute force to big O of A plus B. Our space complexity is big O1, unless of course you count our result as auxiliary space. Okay, we're now ready to code this solution. Okay, the first thing we notice is the function signature. We're given two interval lists now, A and B, no longer a single vector of intervals. Let's make the code changes to reflect the new requirements. We'll demolish a bit of the old code, namely the sorting. We found a better solution, remember. We will, however, keep and retain the merging/pushing logic and actually end up extracting it into its own function. Let's call it something like try merge. In the case that the two intervals aren't overlapping with one another, let's paste the body. And as you can see, we need two things. We need the result as well as the current interval. Let's name it like this to be consistent. The only tweak we make is we no longer have a for loop like we did in the first solution. We have the while loop that will wrap and call this internal functionality. Let's indent a little bit to make it look a bit nicer. And there's that. You'll see that we call this function quite a bit. Okay, let's ready some variables for our while loop. We have I, remember, and we have j. We have our result variable that will return on line 15. With those written out, we can actually start our while loop now, and we keep looping as long as I is in bounds of the A interval list, and as long as j is in bounds of its respective list, B. On each iteration, we're going to figure out which interval between what I points to in A and what j points to in B started earlier. Let's call it the current interval of interest, because that's what I called it in the explanation. In the case that the interval at A started earlier or equal to what j pointed to in B, then the interval in A is the one of interest. Remember to increment I because we've processed that interval then. Now, I did just say that if the interval at A started at the same time as B, we're just going to pick interval A. It doesn't really matter. It's arbitrary. It just means on the next iteration, we'll process the interval in B that started at the same time. Otherwise, if B started earlier, then of course our current interval of interest will equal the interval in B. Remember to increment j if this is the case, and let's get rid of these curlies. Now, when we have our current interval of interest, we want to try to merge it into our result, or push it if it's non-overlapping. Therefore, on line 21, whether the current interval that started earlier is within A or B, we're going to call our helper function try merge, pass in the result, as well as the current interval. And just for readability, I'm actually going to collapse that logic so we can see the rest of the code. We're actually not done yet. After our while loop, there may still be intervals that we still need to process, whether it's in A or B. So if it's in A, then we'll enter a while loop for the rest of those intervals. As long as I hasn't processed every interval in A yet, we're going to try to merge those intervals. Let's pass in that interval, and remember to increment it as well. Otherwise, you'll have an infinite loop. Let's scroll down. Now, if we still have intervals in B, then we'll have a very similar while loop to exhaust all those intervals, and in the same vein, try merge the intervals in B with the results, like so. And when that's all set and done, that is the entirety of the code. It's definitely a bit more demanding, but it's obviously much more convenient if you know this variant ahead of time. Okay, good luck on your interviews. And if you learned something today, please make sure you like, comment, and subscribe. Thanks for watching.